Hello and welcome back to MathsBytes and the binary number series. I really appreciate you being here and taking control of your learning. This is the fourth video and we will talk about the decimal numbers and the decimal number system again. In this video, we will discuss some important properties of the decimal number system, which are also properties of other number system, but with some variability. We will revisit the concept of the placeholder 0 and go into more details, and we'll discuss two new ideas: the most significant digit and the least significant digit. Now, before we dive in, I would like you to try to remind yourself of what the decimal number system is. Please, try to be as exact as possible. Knowing the important concepts well will immensely help you understand mathematics. Mathematics is a little bit like a language. You need to know the exact meaning of certain concepts to be able to make better sense of the whole subject. I will stop talking for a few seconds, and I would like you to try to recall the definition of the decimal number system. Even better, can you try writing it down? Here is the definition. If you couldn't quite remember it, I suggest you start using flashcards, paper or electronic, and test yourself on this and upcoming concepts regularly. Now that we are all on the same page about the decimal number system, let us remind ourselves what the decimal place value table looked like. Can you pause the video here and draw on a piece of paper the decimal place value table? Here is a version of this table. I hope you have a similar table on your paper. If you only have one of the header rows, or you have the two header rows switched up, it's not a problem. That version of the table is conveying the same information in a slightly different way. Also, if your table has a few more or few less columns, it's not a problem, as long as those columns follow the same pattern as mine. A real mistake is if some columns would have the wrong powers, multiples of 10, or if the whole heading would be the wrong way around. Now, why are these variations of the place value table wrong? If we were to miss some of the multiples powers of 10, we would be missing crucial place values. Everyone makes this mistake sometimes, especially when trying to write out the table in a hurry. And in most cases, this mistake gets easily spotted. However, if we were to use a table with missing place values, we couldn't identify all the correct values in our decimal number. For example, using 3090 in a place value table that is missing the thousands, you would misplace the 3 into the 10,000 column. It is worth reading the number out loud once it is placed into the table, so you could spot a mistake like this, as your number is 3000, not 30,000. With the second type of mistake, where the order of the place values is the wrong way around in the place value table, we would totally mess up the values of our numbers. Also, depending on how long we were to write the table itself, the rightmost place value would always have a different value attached to it, like in the examples here. So if we were to place 375 into these tables, the 3 would have the value of 10 in the first table. This same 3 would have the value of 1000 in the second table, and it would be worth 100,000 in the third table. This is clearly a mess. So this nicely highlights the first very important property of the decimal place value table, which is that the rightmost column, the column on the furthest in the right direction, is always the unit place value. With this setup, if we are dealing with a larger decimal number, we just extend our table towards the left without messing up the rest of the place values. So the leftmost place value, the column furthest in the left direction, can be different in any one table. However, the common columns will always have the same place values. Now, let us observe the decimal place value table heading rows and see if we can spot some patterns in them. If we look at the numbers from right to left, we can notice that each column gets 10 times bigger than the previous column. This is reflected in the indices growing one by one. When we look at these rows from left to right, we can spot that the numbers get 10 times smaller. This is reflected in the indices getting smaller by 1. Also notice if you start at any number in the place value table and move 3 places to the left, you will end up with a place value that is 1,000 times larger. For example, if you start at the place value 100 and move 3 places to the left, you end up at the place value of 100,000, which is exactly 1,000 times larger than the 100 we started at. I encourage you to check it with other place values and other numbers of steps. Just play around with the different examples until you develop the intuitive feel for how the table is set up and how to move along it. If you master this with the decimal numbers, it will be much easier for you to move on to the binary numbers. Now, what would happen to the place values if we were to go to the right? For example, let us start at the place value of 10,000 and move 2 places to the right. What would you expect to happen to the place value? Yes, it decreased. And now the place value we are at is 100 times smaller. It is 100. It is also reflected in the index of 10 dropping from 4 to 2. I hope you find these properties interesting. These insights will be useful when we will start to talk about the binary number system and build our binary place value table, as these properties are not unique to the decimal number system. They are fundamental to all number systems. The difference will be that since the bases are different in different number systems, the magnitude by which the place values will grow or decrease will be related to the base of a particular number system. Next, I would like us to revisit numbers like 2005, 40,200, and 130,309 and investigate the role the 0 in them play. Let us place these numbers into the place value table. When you are reading out these numbers, you are skipping over the place values where the zeros are. This kind of says that this number is missing some values. Now let us see what would happen if we did leave out those zeros. 2005 would become 25. 40,200 would become 42. 130,309 would become 1,339. Those numbers without the zeros are very different from the numbers with the zeros. So these zeros are signaling us that, for example, 2005 have 2000, no or 000, no or 010, and 5 unit, opposed to 25, which has 2 tens and 5 units. I hope that through this example, you can see that those zeros are vital in achieving the desired value of the number overall. And even though these zeros have no values, they are holding the place value, so we can signal that a specific number has nothing at a specific place value, such as 2005 has no 100 or 10. Hence, we call them place value holders. In the last part of this video, I would like us to talk about 2 more concepts: the least significant digit and the most significant digit. Here are the definitions for them. Least significant digit: the digit with the lowest place value. Most significant digit: the digit with the highest place value. Now, let us identify the most significant digit and the least significant digit in the following numbers. The most significant digits are 4 at the place value of 1000, 1 at the place value of 10,000, and 3 at the place value of 100. The least significant digits are 9 at the units, 1 at the units, and 5 also at the units place value. Now it's your turn. Please identify the least significant digit and the most significant digit in the following numbers. Feel free to pause the video here if you need some extra time to think through these questions. Remember, this is not a race against time. Here are the answers. In this video, we first reminded ourselves of the definition of the decimal number system and the decimal place value table. Then we discussed what mistakes one might make when trying to remember the decimal place value table, for example, missing out one of the place values or switching up the order of the place values, and starting with the unit at the leftmost place rather than the rightmost place. These mistakes can be quite common for students first learning about the number system, and we went into details discussing them. Switching up the order of the place values is quite problematic, as then the place value table would have different values attached to it at the right rather than at the left, and placing the same number into different lengths of tables would give the same digit different values in different lengths of tables. For example, the 5 in 945 would be at the place value of 1000, 100,000 or 10 million in these tables. This would be chaos. So the smallest place value, the unit, has to be at the rightmost place. So regardless of the length of the place value table, the digits would be in the right place value for every number every time. Once we established the right way to set up the decimal place value table, we started to observe its properties. We have spotted that as we move along the place values from right to left, the values are being multiplied by 10 from place to place, while when we move from left to right, those same values get divided by 10 place by place. These patterns are also reflected in the exponents of the place values increasing one by one when moving from right to left, and decreasing one by one when moving from left to right. And finally, we have introduced two new concepts, the most significant digit and the least significant digit. The most significant digit is the digit in the number with the highest place value, and the least significant digit is the digit with the smallest place value. For example, in the number 42,507, the most significant digit is 4 with the place value of 10,000, and the least significant digit is 7 with the place value of 1. You are probably pleased to hear that in the next video we will start to discuss binary numbers. Trust me, if you have stuck through these videos and made an effort to learn the concepts we talked about, you will find the binary numbers simpler to understand, as you have something familiar to link them to. I hope to see you in the next video, but until then, keep learning one byte at a time.